So let's start the session now. So EHRP stands for here, guys. So Enhanced Interior Gateway Routing Protocol. It was the Cisco proprietary. So now it is belongs to open standard now. It has become open standard. It was only configured only for the Cisco devices, guys. Your EHRP. So now not only Cisco, so even they can configure it in your other non-Cisco devices as well. So IGRP, so advanced version of IGRP is your EIGRP. So the other protocol which I'm going to discuss next week, that is your OSPF. So this is a basic characteristic of your EIGRP, guys. You can see it is a hybrid protocol. It uses a dual algorithm. This is a dual algorithm, guys. It is dual algorithm, means diffusing update algorithm. So it maintains topology database, rapid convergence, and it is very reliable communications. So it use TCP protocol. It also works same thing like your TCP/IP for the reliability, transmission control protocol. So as I told you that, so EHRP was the Cisco proprietary routing protocol based on your interior gateway routing protocol. So previously, so it was IGRP. So now they have advanced EIGRP. So we are using almost many organizations still they are using your EIGRP or OSPF, most of the organizations. So it was released in 1994. So unlike EIGRP, so which was class full routing protocol, EIGRP supports CIDR and VLSL. Means it also supports your subnetting. It is possible for one or most popular routing protocol in today's use, guys. So most of the EHRP and OSPF. So any one of this protocol, so they are implementing in their network infrastructure. So EHRP boosts fast convergence time, improve the scalability, superior handling for your routing loops. Okay, it has the capability for handling your loops in your network. It also often described as your hybrid routing protocol, like offering your best distance vector and link state algorithm. So it will calculate which is the best part. So for routing the traffic, selection of the routing traffic, because as you know, if you talk about any big infrastructures, so this play a very major role EHRP routing protocol because of its reliability and scalability. So one more thing, good thing is guys, so it has got very fast convergence. So compared to OSPF, okay, so EHRP is very fast than your OSPF. So as I told you that EHRP are compatible with each other. EHRP offer multi-protocol supports, but IGRP does not. So that's the reason. So we are not using that. We are not going to discuss your IGP. Communication via your reliable transport protocol. So best path selection. How do you select these best path selections? Using your diffusing update algorithm. So this is algorithm which is going to calculate the best path. Is also going to calculate a metric calculations. So improve your convergence time, reduce the network overhead. So if you compare, as I told you that, so a conversation is very fast. So even compared to your OSPF. Okay, so EHRP supports rapid convergence, reduce the bandwidth usage, multi-network layer protocol. So it's going to work in all your IP routing. So yeah, Apple type routing IPX protocols. Okay, it supports almost all applications and your lower layer in your OSM model also it supports. So it maintains three table guys. So we have to remember this. So EHRP maintains three tables. It maintains your neighbor table, topology table, and routing table. So these are the three tables which maintained by your EIGRP. Okay, so as you know that the three conditions that must be met for the neighborship establishment. So first it will send hello or acknowledgement received. So depending upon the EAS number. So what is EAS number means autonomous system number guys. We start from 0 to 65,535. This number of numbers we can give, but whenever you want to configure the EHRP, your EAS number should match. If you give EAS 100 here, so here also we should give EAS 100. So then only they will exchange their updates. Okay, the identification of the metric will be based on your K value. What are those K values? So K1, K2, K3, K4, and K5. So K1 is your bandwidth, delay, load, reliability, and MTU. So these are the parameters which is going to calculate your metric. Okay. By default, EHRP is going to calculate these two parameters. By default, it will calculate bandwidth and delay. What is the speed of the link and how much bandwidth it has. So based on these two is going to calculate your metric calculations. And these are the thing extra features. So that will call your advanced EIGRP. So we have to remember guys this. So I might ask the question at any time. You have to remember. So what is the AD value for EIGRP guys?
110.
No,
90 touch.
90, right? You have to remember guys this. AD value for EIGRP is 90. Okay. For AD for OSPF is 110. Okay, for RIP, this is OSPF. For RIP,
120.
120. For static routing,
1.
1. Okay, for IBGP,
200.
BGP is
yes, very
200.
good. EBGP,
20.
yes, guys. This is very important, guys, because maybe you will be having a lab exam, lab assessment. So I'm not going to configure, ask you to configure the EIGRP. I'm asking you please configure. Okay, administrative distance 90 with the given network topology. Means you should understand that I'm asking to configure the EHR. Okay, because you know most of the network engineers, so they will see only the AD values. So how is going to calculate the metric guys? Okay, so as I told you that, so it will be totally depending upon your making the routing discount as a lower metric, the better. Okay, how is going to calculate your bandwidth, delay, load, reliability, and maximum transmission unit. So by default, as I told you that is going to calculate bandwidth and delay. So if you are not given any value for this one, by default is going to calculate your bandwidth and delay. So what is the bandwidth guess? So bandwidth is nothing but a width of the pipe. Okay, and delay is nothing but your length of the pipe. So he's talking about this one guys. So this is the pipe. Okay, he's talking about bandwidth is nothing but a width of your pipe. This is your bandwidth. So and this one we'll call it as your delay. How long it has to reach. So same thing your RIP guys. RIP how many hop it is going to work? 15, right? RIP is going to work maximum of 15 hop. Okay, and your EIGRP is going to work maximum of 255 hops. You have to remember, guys. So neighbor table, how it is formed? The most important table in an EHRP, store address and interface of the neighbor. So it's as simple as these guys, because whenever new neighbor has come to near at your home, okay, so first means you have to, whether you want to communicate with them or they will come to you. Anyone, you have to start initiating the conversation, right? So obviously we'll send hello, right? Hello, or we'll send the hi message, right? Neighbor table, same thing here. Okay, whenever you advertise your network, it will send a hello message. So please give me your updates. Once this is my update, please give me your update. Means you will introduce yourself, right, to your neighbor, right? So this is how it will start initial configurations. So there it will maintain your neighbor table information. In topology tables, so it will ask to the routes. Please give me the information about all the routes. This router is requesting to this guy. And also it maintain the topology table. So for this R1 router, okay, imagine this is R2 and this is R3 and this is R4. Okay, it also maintain the topology table. So how it is maintained? So it maintain the R2 topology table, R3 and R4. So he will think that, okay, R2 is directly connected, R3 also directly connected, and R4 is indirectly connected. It maintains their routing table and also the path. Okay, the path how is going to select? So it's going to, okay, when I reach to R2, I can get the R4 updates. Okay, same way. So when I request for R3, so I'll also get your R4 updates. Okay, so this is how they maintain the topology table. It's like this, guys, because in the social media. So I think in the Facebook or any social media, they'll ask like when you connect your friends. Okay, so even they'll pop up, right? So there's a reference. They'll pop up friends. Okay,
Yeah.
they will come to know how many people has been connected with your friend.
Mutual friend,
Like mutual friends. How many people are connected? Same thing here. In the topology table, made up of EHRP routing tables is your autonomous system number. So these algorithms take information, calculate the lowest cost routes to the destination. As you know that your lowest cost is the best route. Okay, by tracking the informations, EHRP router can identify and switch to alternate routes very quickly. Once the metric calculation has been done, lowest cost, again is going to calculate your alternate route, because this is a very smart protocol. So it's not depending upon only one link. It's going to calculate the two links. So maybe you connected with one router, you have connected one more router here. So they will calculate the both the things, and they'll think that this is your uh, successor route, and this will become your feasible successor. I mean, this will work as your alternate link. If things list go down, so they can route this topic to this way. The information that routers learns from dual is determined by your successor routes. Okay, once the metric calculation when the lowest cost has been calculated, okay, so what is going to do? This guy will become your successor route, which in terms used to identify your primary or best route. So, okay, the EHRP route maintain your topology table, also learn the routes to destination and maintain your topology table. So it update the table. So even it's not like this, even if it is one more router also you connect it. So this also it maintain the topology table. It update its topology table. Because when you connect, right, even the social media also, if you request any friends, so friends, so once they acknowledged. Okay, they accepted your friend request. So you will update right from your account. You come to know that, so you'll become the friends. Like this, you'll update your how many people are connected to them. In routing table, okay, the successor route are selected as your primary route used to reach to your destinations. So your dual algorithm is going to calculate the successor routes and place it into the routing table. That is in your topology table. So you can have up to six successor routes of equal and unequal load balancing. So here this dual algorithm going to also calculate a feasible successor that act as your backup routes and place them into your routing table. So product of successor, if the router goes down, so it has the lowest cost, then it will become your current successor. If there is a no feasible successor in the table, send the query. Okay, it will send the request, guys. If there is no feasible successor, there is no alternate, it send the request to whichever neighbor router connected to form the adjacency. So multiple future successor of the destination can be retained in the topology table, although it is not a mandatory. So it's not like that only one successor, feasible successor. They might be having 2, 3, 4 successor route also there. Okay, it's not totally depending upon one successor routes. The basic terminology of your EAGRP. Okay, EAGRP router belongs to the different autonomous system number, so don't automatically share their update informations. Okay, if the your AS number here, if you maintain 100, okay, or for other router you have given 200, okay, they will not form the adjacency. Okay, the only time EAGRP today's its entire routing table is when it discover the neighborship. Until and unless it's formed the neighborship, it's not going to share your any updates and form an adjacency it with through the exchanging the your hello packets. Like you will send the hello packets to form your neighborship. Right? It's as simple as these guys, because you know when the new neighbor has been come, so you will go and contact them, you will give all your details. No, right? First we will form the neighborship, we'll send the hello message. It will give there some basic details. So once it has been neighborship has been formed, so then you can update details like what is this area about what are the facilities are available in those area. Same thing like this here. When this happens, both neighbor are advertise their entire routing table to one another. So once they have built up the neighborship, so then they will exchange their routing updates. So after each learning of the neighbor routes, only change the routing or propagate. In the sense like once they have formed the neighborship, so then only they will exchange your routing updates. He has given some example, guys, to reach to this we can see. Who is the best, guys? This is Mumbai, okay, Bangalore and Chennai. So who is the best here? Destination is so 172.16.100.0. Okay, source is 100. This is 100. Okay, who is the best route? You can see right. 10 Mbps, 100, 1.54 Mbps, 250, 56 kbps, 1000. I'll change the values, guys. Please try to answer it. So this is my link speed here, and this is my link speed here. Okay, so which route is going to calculate now to reach to Chennai or to reach to Bangalore from Mumbai to Bangalore?
1544 Mbps.
Hmm?
1544 Mbps means 250.
250. Okay, this is the best route, right?
Yeah.
Yes.
This is the best route. Okay, so this will call your successor route. And this guy will become your feasible successor. Means backup route. This guy will become your backup route. Like this, we'll be having up to 6 feasible successor, FS. We'll call FS, feasible successor. Okay, so what is feasible distance? Okay, report distance. The lowest calculation of the metric reached to the destination. This is the route we will find. So as I told you that, okay, feasible distance is the one which has got the lowest cost. Report distance, okay, which will form a neighborship to the specific destination. Okay, we need some scenario. You want a specific separate path to reach to your neighbor networks. So in that scenario, so we will use this your report distance. And also it also maintain the interface information through which the destination can reach. It also, when I reach to this interface, I can get this all details from this neighbor EHRP router. Okay, route status. So your route status are identified either by passive, which means that router is stable and ready to use, or active. Same thing here is going to calculate your metric calculation here. Okay, who is the best path to reach to your destination? Okay, successor route also will call your current route, and feasible successor, as I told you that it is your backup route. Okay, so there might be a multiple successor for the destination can be retained in the topology table. There might be multiple, so we can use it. So it uses the RTP, reliable transfer protocol. Okay, so EHRP can call RTP protocol for a reliable or unreliable services. EHRP uses the reliable services for the routing updates. Okay, by sending your hello messages. So it also works in RTP in transport layer protocol that guarantee order of your delivery of your EHRP packets to your all neighbors. Okay, so this is what the EHRP has become very popular because of its reliability. It uses your acknowledgement. Your data, your packets will be not lost. And IP networks host use TCP to sequence packet and ensure that timingly delivered. RIP use only UDP for sequential number. UDP use. So here EHRP, it uses a timing delivery. It maintains the timing also. What timing has been delivered. And as I told you that EHRP is protocol independent and does not really on TCP/IP to exchange the routing information the way RIP and EHRP OSPF do. So it's not totally depending upon your TCP/IP because of it is RTP, reliable transfer protocol. The concept same thing they have taken from TCP/IP guys. The concept of same thing as it has taken from TCP/IP. EHRP use RTP as known as your proprietary transport layer protocol, guaranteed delivery of your routing information. With the RTP, EHRP can multicast, unicast to the different pair simultaneously. It has got capability to send the updates to router which is connected directly by using sending the multicast and unicast message over and over and again. Okay, so this is the algorithm. So where we are using to calculate the best path. So when a dual takes the maintain the table, okay, your loop free path of your every destination. This table refers to your topology table. Okay, so dual saves all the path in your topology table. The least cost path is copied from the topology table to the routing table. it calculates the neighbor. So many neighbors has been connected. So it will calculate the best path, who is near to me, who is the feasible. So that update information will be stored in your routing table. You're following me, guys, right?
Yes, Taj.
Yes, Taj.
Yes, Taj.
So as I told you that, so hence name diffusing update algorithm. So it send the query to the neighbor, who in turns may query their neighbor and so on. Okay, it will try to initiate the connections. Even it maintain your loop-free path. If not found in the topology table, routing table, your computations must be occurred. Again, to recalculate. Okay, again is going to recalculate your routes. Okay, it also supports your VLSM. Can be use up to 30-bit subnet mask to point network. Because subnet mask is propagated with every route, EHRP is supposed to use your discontinuous subnet also. If it is a different subnet VLSM values, also it's going to support it. That is a very good feature available here. A discontinuous network is one of the that it has 2 or more subnetwork of the class full network connected together and different classes. It also supports class full and classless also. Your EHRP. Maybe you are connected a lot of subnetted in your organization, different department with a different VLSM value is going to support that. You can see discontinuous network. You can see this guy with the network 10 dot networks. You can see this is 1 dot networks and this is 20 dot network. Same thing. So this lab we are going to do it now. Okay, very simple lab. So they are going to exchange their updates. So how do we configure? Same thing how we configure yesterday. Here just router, we have to give the ES value here. Okay, ES value where I told you that I think 0 to 65,535. Okay, any value. So make sure that ES value should be same for the both the neighbor if you want to form the neighborship. Okay. And network number. Okay, so network number might be your 192.168 1.0. Okay, that's it. Okay, router EHRP if you give 100 and use this network and this is how to configure your EHRP. Okay, so here he has given the complete command. So please notice here EHRP 100 and here also he has given EHRP 100, right? ES number. Though both the routers should be same in your router A, okay, on your router C also. So we have to advertise your network. Okay, then here you have to advertise your network. So then they will exchange the updates. So here in router B also running one more EHRP that is 10. Okay, so then they'll maintain. So which are the table they maintain in your router A? First thing is they are going to maintain your topology table, right? Then first neighbor table, guys. Neighbor table and a routing table. Same thing here. Your topology table, your neighbor table, and your routing table. Same thing here. It will form your neighbor table, your topology table, and your routing table. They maintain means they will exchange their updates to each other. He'll give updates to him, okay, and he also give the updates to him. Same thing, this guy will give updates to him. Okay, again he'll updates to him. Same thing, this guy as well. Okay, that all informations will be available in these 3 tables. Okay. The configuration, guys. So EHRP, how do we configure? So we can see EHRP 10 he has given and network he has advertised 200 network and this networks. Same thing here, EAGRP 10. So he has advertised his networks. Okay, so configuration is very simple. Same thing like RIP yesterday. How did you configure? Verification, show IP route EAGRP. If you check here, show IP route EAGRP, show IP EAGRP topology. Okay, commands here. Show IP EAGRP traffic. Okay, it will show you like where it is routing. Okay, these are the administrative distance gas. As I told you that starting itself, you have to remember. So connected interface directly, ED value is 0. For static routing 1. Okay, for IGRP summary route 5. Your external BGP is 20. Internal enhanced IGP is 90. That is your EAGRP is talking about. IGP, so we are not using that. OSP of 110, ISIS 115, RIP 120. Okay, your external routes 170, internal BGP 200, unknown is 255. Okay, if it is a 255 means it is unknown, means we cannot reach that. Reach there. We will not get any updates. Okay, so can you jump to lab now?
Yes, Taj.
So let me open that. I think so. Let me explain about this one as well. As I told you, EHRP maintain your neighbor table, topology table, and your global routing table. So these are three things is going to maintain. Same thing. What are the things I discussed? Okay, so let me start my Cisco packet tracer. For you to also every time it asking us.
Yes, Taj. Yes, Taj. It is asking for sign in every time. After few hours or few minutes.
It's not asking.
What about others? Same thing is asking.
No, Taj.
They
Directly
ask
log in.
keep me logged in for 3 months.
Because
Not asking.
I have a lot of account, but it's still it asking.
Okay. For me also asking login every time. If you open the Cisco packet tracer, it will ask login.
Okay. So here what I'm going to use, guys. So let me open your files. So I'll use this, guys. Yes, just I will rename. I'll use the same topology yesterday what I did. This I'll make it EIGRP lab. And this is our lab 3. Okay, right?
Okay, Taj.
Okay, same thing. Just I'll replace with this one EIGRP. So remaining all are remain same. This also will do the lab. I think yesterday we configured RIP, right?
Yes, Taj.
If you ping from other network, I think we can able to reach. I think 20.1 is there, I think. Yes. 2 also is there. I think it's not connected. Okay, so how do I remove this, guys? It has also loopbacks.
No, configure global configuration mode.
Okay, show run. Check which are the things we configured here. Then remove that. right?
Yeah.
So these are things we should remove, right? 10 network. Okay. So how do you remove, guys? Okay. So best way to remove this one is go to global configuration mode. No router rip. Show run. Everything is removed, right? Can you see?
Yeah.
So if you type show IP route, okay, show IP route rip, we can't see any routes. Correct?
Yeah,
Okay.
that's
Okay, same thing. You just remove the rip now. Because already rip file I copied. It is available, guys. Show IP route rip. So this guy is having. So go to global configuration mode, row no router rip. That's it. Show IP interface brief. Okay, still we have the IP addressing. Show IP route. Show IP route rip. Okay, it is not there, right? But we have the loops, right?
Loop back is there, no?
Let it be loop back, no issues. Okay, the IP address which is there here. Okay, what are the IP address are there here? I think 10.1.1.1. Okay, and these guys 10.1.1.2. And this is I think 122, 168. This is 10.1, I guess. 182, 168, 20.1. So these are the IP addresses which are there. If you check right now, they show IP EAGRP. Okay, so no routes are available. The configuration is very simple. So now I'm going to configure your EAGRP, guys.
Raj, what is the
Router.
main purpose of the loopback IP?
It is a virtual interface. It is used for testing. It also we will also give for the routers, so that your router will as you know that virtual interface will never go down.
Okay.
Okay, that is also used for testing. Okay, so now I'm going to configure your router, this EAGRP now. Just go to global configuration mode, router EAGRP, give the question marks, right? So as I told you that, so it will support 1 to 65,535 autonomous system number. Okay, it is an independent number. Okay, so where we can configure your that number of EAGRP to the network. Okay, so I will give 100 here to my routers, give the network, give the question mark and network number. So I have to give my network. Okay, before that, check which network do we have. Do show IP interface brief. So we have 10 network, right? You can see, right? This is our 10 network, right? Network 192.168, 10.0. So give the space if you ask the question mark. So EHRP wildcard bits also it will accept. Okay, if you want, you can give the wildcard mask because right now, so in this network, we have not done any subnetting. That the reason is not required, right? Okay, there is one more network, right? 10.0.0.0, middle one, this network I'm talking about.
That is 10.1.1, right? We assigned.
Okay, it
That is
starts from
IP.
0. That is
Okay.
IP address.
Okay.
This is network.
Yeah. Now show IP route EIGRP. So still it's not forming the adjacency, right? Same thing, we have to configure this side. Okay, so router EIGRP 100. Make sure that your autonomous system number should be same. Okay, network 192.168.20.0. Okay, so even I think 10.0 also we should configure. So as we can see, it's forming the adjacency, right? New adjacency has been formed. If you check here, here also is forming, right? Router 2, right?
Yes.
Check this show IP route EHRP. We can see D. What does the D indicate? As we can see, your administrative value for EHRP is 90, right?
Yes.
Right. And this is the metric calculation, what it has calculated. It's going via this IP, okay, with this interface. So this is the metric calculation he has calculated.
That it is automatically
So,
calculated, metrics
yeah,
value.
automatically. As I told you that, by default, it will calculate bandwidth and delay, EHRP. If you check this side, so IP route EHRP. Yeah, so here also is calculated your EHRP. So if you type show I just IP route, okay, so we can see, okay, D stands for your EHRP.
EHRP. Okay.
Correct, guys? Okay, so I think we can able to ping now. 192.168, 10.1. Okay, I think 10.2. I think 3 also I can ping. Oh. Okay, so there's a command like show IP route EHRP. If you type the question mark, okay, show IP EHRP question mark. So these are all the commands we can use. Show EHRP interface. So which are the interfaces connected to this router one? Okay, these two interfaces are connected. Okay, with their reliability values and your flow tab and routes. Still, we don't have routes because we are not generating any traffic here. So the same thing for that is neighbor. So who is my neighbor? Okay, so neighbor is 10.1.1 and interface name is this and hold on timing. So how long is taken? I think 2 minutes means since we have started. And show your topology table. Okay, so you can see the topology, how it has been connected. So 10.0 network, this is one successor and feasible distance is 281. This is the metric calculation, how it has been calculated. Okay, so P stands for your passive. Okay, so one successor routes, one successor route. So we here also yes calculate your metric calculation. And this command is very helpful. This is the other command, show CDP neighbor. Okay, this is a Cisco command. So this command CDP is nothing but a Cisco Discover protocol. So this CDP command, it will help you miss which are the neighbor connected to your router. We can see all the router because this command is very helpful because when you have the lot of racks connected, each rack, so you will connect it 15 to 20 or 30 routers and switches. In those scenario, we cannot go physically and check like for routers how many devices are connected. If you issue this show CDP neighbor, we can see like which other devices are connected. We can say right for R1, so router 1 is connected with this interface. Okay, and which router? ISR 300 router with gigabytes ports and switch is also connected with the switch, right? Very helpful command. Okay, one more command is your traffic. Okay, so here it will show you the detailed information like hello and sending receive, how many times he has received. Update send only 2 times and 2 times received. Acknowledge 2 times and 2 times received. Okay, this is the basic command. Okay, you can do it from your side. Okay, we can see we have some other loopbacks, right? Still we have 4 loopbacks, right? You can see, so you have the 4 loopbacks, right? So right now, how many we can see? Show IP route EIGRP. Just we can see only 192.168.10 dot network. Okay, so can we configure now for loopbacks also? Router EIGRP 100, give network 172 dot. Okay, I think this is 30.1.0 and 2.0, 3.0 and 4.0. That's it. Same thing this side. So IP interface brief. So let's configure this one as well. EIGRP 100 network 172.10.1.0 and here is 2 and here is 2. P 4. That's it. No IP route. Use that. So we can see, right? These all things it has learned now. Symmetric calculations are same for all because these all loopbacks, right? You can see it is 130816. So let's check with this R2 now. Show IP route EIGRP. You can see here also it's learn the network. So let's check this. Can you able to ping now? So 172 dot, let's take into 10.1.1. I can reach, right? So there's a one on the network 10.1.1.1. 21 dot network is not there. You can see right in the table. It is not there here. Right? It is not there. I think 2.1 is there. So 3.1 is there. And 4.1 is there. Can reach, right? Same thing, we can also ping from this to this server to this server. As you know, the first time is going to fail it. Right? So I can reach to all these PCs now. Why these guys? No IP address. Oh, yes, taken up pipa. Yeah, so now he has taken. Now I think can able to ping. Yes. This to this. I think here I think DSCP configured, but we are not updated here. That the reason is not pinging. Yeah, so I think now we can able to ping. Yes. Yes. Understood, guys? EHRP configuration. Any question, guys?
No,
DNS
sir.
server is mandatory to give or else
Hmm?
no need of configuring of a DNS server. Is it mandatory?
It's depending upon the organization, Kranti, because in your organizations, okay, your DNS server will be there, right? Your domain name will be there. Suppose entity.global is there, right? This is our domain.
Yes.
Right. So in a scenario, we have to give the DNS. I think what is DNS? It is replication of IP address, right?
Yes.
Right. Because for DNS, we are giving 888 for the Google. That is a standard where we can use it.
Yeah.
Even for the real time also, we are using it.
Okay.
Okay. So if you are using, suppose like suppose you have your company, Kranti.com. For the Kranti.com, what is that? There's a domain name, right?
Yeah.
So your domain name also is replicated to the IP address, right? It is nothing but IP address.
Okay.
Right. Because why I'm giving every time, because to make you habit that please give me the DNS value also. As per our, because we are doing practice, this is a training part. Okay. So it is optional.
Okay.
Okay.
Okay, that's
Okay. What about Veena, Sharath, Punit, Chandan, Ratnakar? Understood, guy? EAJRP.
Understood, Taj.
Amisha?
Understood, Taj.
Yes, sir. Understood.
Yes, guys. I think you can able to do it, right?
Yes, Taj.
Yes, Taj.
Okay. So can we capture the packets and analyze the EHRP packets, how it's look like?
Yes, Taj.
Okay. Packet capturing. So let's do that, guys. So what I'm going to do, I will take the stimulation. Okay. So let's ping from my this server to this server. Okay. So let's start. We can see, right? It's pinging, right? Can you see? It's sending the packet.
yeah, that's
Okay. So again, it reaches to router. And then it's sent to this router, and this router will send to switch. Once switch received, it will send to your switch will know that server IP. So once is getting reply, okay, is going to acknowledge reply back. Is getting reply, right? So how it look like, you can see here from where to where, how it's moving from switch to switch, from where it's moving. Now we'll get the reply now. Okay. Now
or it'll take
reset
30 seconds, right?
It's all depending upon on this thing. Okay, now we'll deep analysis like how does it look like now. So again, I will take the stimulation. Okay, so I'll just ping to same from this server to this server. Okay, so what I will do, start. This is the start one. Okay, just open this packet once it is reached to your server. Okay, now it has reached to server. Just click there. It will open the packet. Okay, meanwhile, I'll stop it. So now we can see the details of this packet, guys. Okay, OSA model, right? Can you see? OSA models right now, as you know that, so it is your router is your layer 3, right? Router is your layer 3. So you can see the layer 3 IP header source IP address is 10.2. Okay, okay, and your destination is 192.168.20.4. That is your this server IP address. So this is the server IP address, right? In layer 2, that is Ethernet 2 header, so which has got the MAC address. Okay, this is your source MAC address, and this is your destination MAC address. And layer 1, the port gigabytes from where to whom it is connected. This is nothing but your gigabytes port number. Okay. If you talk about your outbound, okay, outlay, layer 2, your source IP is 10.2, same thing here. Okay, here also same. If you talk about inbound PDU, so how does it look like? I think last week I told you, right? How does like IP header? We can see this is your preamble. Okay, this indicate that starting and ending of your packets. You can see this is your destination MAC address. Okay, and this is your source MAC address. Okay, the type, what kind of type it is. So this is your layer 2 gas, what I am discussing here. Okay, now when you see this IP, you can see right IP here.
Yeah, Taj.
You can see right, this is IP means this is the layer 3. So layer 3, what it contains, this is the IP header version 3. Okay, and your DSCP, okay, and your time to live 255, and your which protocol we are using, your source IP address, you can see right 10.2, and your destination MAC address, and your data, your checksum, okay, and your flag bits. Okay, so which type of protocol we are using? We are using ICMP to check the connectivity, right? So in ICMP, okay, it maintains the sequence number 6. Okay, checksum it is error free or not. Okay, so variable size your PDU, it may vary your data. Okay, if you talk about the outbound, the source IP remains same and destination also remains same. Okay, let's continue again. Once it has been reached, once this guy reply, then you'll open this packet. This is our reply, right? Now it's reached to server. Now server is going to reply, right? Your for your ping command. It's come to switch, and then we'll open that. Just pause this now. Now we can see source IP address is 20.4 now. Notice, guys,
Yes.
and destination is 10.2. Right? The ways about if you check, okay, because we have opened from switch, right? It's talking about your source MAC address also change and your destination also change. And if you check here, so as I told you, it has become changed now. Outbound PDU details, we can see your address has become changed. So now we'll continue the packet now. Is it interesting, guys?
Yes, Taj.
Yes, Taj.
Yes, Taj.
Yes.
Yes, Taj.
Veena, you're following Veena, Amisha.
Yes, Taj.
Yes, Taj.
Yes. Have you done yesterday static? I think Amisha has struck. So let me stop now. Okay. So this is a very simple lab, guys, for the EHRP configuration. So next lab will do for your using 3 routers, using loopback also. Okay.
Sure, Taj.
Okay. So this is our next lab. Just change this one to EHR. Okay. So now, guys, as you know that here right now it's working your RIP, right? RIP is running. So I want you people to remove this RIP. Okay. remove RIP in all configuration and don't remove your IP address. Okay. So what I will do, so we will take 10 minutes break now. Okay. So after 10 minutes, the same time, so I will give the access to you guys who is interested to remove the configuration, guys. Anybody?
I will do. Taj.
Or-
I will
Who?
do. Srinidhi.
Trainig, okay. Yeah, Sridhi, I think you can now.
Now or after the break?
No, we can do it. Other guys, they can take break for 10 minutes. Okay, so let me remove that. So let me open this. Yeah, so just remove your these things. And you people can take break, guys. 1 second, Srinidhi. So let me make it. I'll mute it from my side so that you'll not have the interruption.
Hi, Taj, shall I do now?
That will be dispatched to my distributed address, right? Yeah, the thing is like, talking about my residential address, it's very far. I mean, it's a remote place, right? So there is no point of, dispatching that cadet craft to town. If it's possible, you can dispatch my location where I'm staying now, which is Bangalore. So that So is there any way for the amendment? I mean, talking about changing address. I have to. So is it possible? Because if it's possible virtually, then I can move forward. Or else, because you said that I have to visit, physically in the bank premises, right? So is it possible? Is there any way? Okay, you do one thing, before I move forward. You just send me all those details, okay, what all those benefits I'm getting from the card. So I'll go through that and
IP router.
Hello, Srinidhi. Hello.
Yeah, Diksha.
I think here you can write no IP route.
Yeah,
IP
just
router.
by mistake it came. Yeah.
Okay.
Controlling is
You need
it.
to do backspace.
Huh?
Backspace.
Yeah, yeah.
Hmm.
No IP router.
IP route or IP?
No. No. I think no router. We have to remove this one, right? RIP.
ओके
That's what.
ओके 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 ठीक है ठीक है
Oh, sh- What is this?
There is no accessing other system.
I hope I think, guys, I'm back now. Guys, are you there, all of you?
Yes, Taj. Yeah, we are here.
Yes.
Yeah. Trainnig done. Remove the rip. Let me check. IP route rip. Yes, fine. Here is removed. Then check this side. Okay, fine. Check this router. Fine. So guys, so now what I'm going to do, guys. So now I'm going to configure your EIGRP. Guys, all are present, right? All they came back, right?
Yes, Taj, we are here.
Yeah, yeah.
Yes, Taj.
Yeah, fine. So this time. So we'll do the configuration using telnet gas. So how means? So as you know that each time we are going to each router, we are going to configure the EHRP, right? So this time what I'm going to do, I'm not going to the any router. Okay, I'll go to one router. Okay, I will connect one laptop to one of these network. Okay, from here, I want to access all these three routers. Okay, then I will configure EHRP. So how do I access this all three routers? I don't want to click every time router 1, 2, 3 and do the EHRP configurations. We can do it. OK, so this is other method I'm telling you how do we can configure. In this way also we can able to configure. OK, so I want to access from this one. Let me get IP address from DHCP. Why these guys not getting IP address? Is it DHCP configured here? So IP DHCP. Let access with this router, I think.
Hi, Taj.
Yeah. Okay. Means there is a problem with DHCP, I think. We are not configured here DHCP. Let's configure it because it has configured 1. Network. Okay, right? The IP DHCP pool, I'll give entity network 192.168.10.0. Okay, so default router ID is 192.168.10.1. Okay, show IP DHCP pool entity. Okay, so now it has been configured these things. I think now I should get the IP address. Yes, so now I'm getting it for all the PCs. Yeah, so I'm getting all the IP address now. Yeah. Okay, I want to access from this router. Okay, imagine this is you are the network engineer. So this you are connected one of the switch. So through here, you want to access this router 1, 2, 3. Then we access this. Then we configure the EHRP now. Okay, for that, what we have to do? We have to configure telnet, right?
Yeah.
Correct?
Yes, yes.
Yes,
Okay,
yes,
so,
Taj.
okay, so create username. So username I will give Cisco. Your privilege level I will give all rights. Okay, so password also I will use Cisco. Okay, line VTY 0 to 4. Okay, login local and save. Okay, so let's check now. I should be able to access the telnet now. Now we'll access telnet by using this one. Okay, I want to access my first router, that is 192.168.10.1. Okay, so I can able to access, right? Username is Cisco. password also Cisco. Right, I can able to access your router one night, show IP route, read. Okay, you not configure. Now same thing I want to access for your router 2 also. Exit. Cisco. Yes. I will close here. So again, I will access either I can go command prompt also. So let's configure telnet. Second router 192.168.20.1, right? Okay, it's not accessing because we are not configured telnet there also. Right, so let's configure telnet here. So I'll create same username. Username I will use Cisco. Privilege 15, password Cisco. Okay, line VTY 0 to 4. Login local. Same thing this side. Username Cisco, privilege 15, password Cisco. Line VTY 0 to 4. Login local. Okay, so now I think I should be able to access now. Thing now. Is the 20.1 is correct? Check what is IP address.
Yeah, yes, Taj.
So IP interface brief. Okay, it's a 2.100 guys, correct? You can see, right? This is your 2.100. And check for this guy. Show IP interface brief. This is 3.100. So I think now we can able to access 2.100. You know why it is not accessing, guys?
WAN is not configured.
Hmm?
WAN link is not configured, Prakash. Because that's a different network, right?
Different network. We are because there is no communication yet between each router. Right? They have communication within their network. If I ping from this laptop to this router, so they can reach each other. Right? They can communicate with each other. Right? From this PC to this PC, they can communicate. But when I ping to this server to this server, okay, it's fake. Okay, the reason it's not allowing to access because there is no communication between these two. Okay, first thing is we have to configure your EHRP first. Make them communication, then you can access your telnet. Okay, so how do I configure your router EHRP? I will give 100 same. Let me put my charger is coming down. Okay, which are the networks? First check the network. To show IP interface brief. So I have my 10 network, right? So network 192.168.10.0. Okay, and one more is your 10 network 10.0.0.0. Okay, so now go to second router. Router EAGRP 100. So this network is how much? What is the network for this? This guy is 2.100, right? Okay, 192.168. 2.0 network. And here again 0. Now we can see adjacency is forming, right? And there is a other network, right? 20 network also. Your right side of this router, which is connected for your R3, right? And they show IP route EIGRP. So one network has been formed. Now go to this last router. So router EIGRP 100. Okay, network 192.168.3.0 and network 20.0.0.0.0. So now this guy also formed the adjacency. Show IP route EIGRP. So we can see this all network has been learned now. Right? So can you able to access now telnet, guys? 2.100. Correct? Now is allowing us, right? Cisco. Now I'm in R2 now. Show IP route EIGRP. I can see, right?
Yes.
Right? So exit. Go for R3 now. 3.100. I can able to access Cisco. Which is R3, right? Show IP route EIGRP. Correct. I need not go to any router now. Okay, now from this router now I'm in R3 now. So I want to configure the loopbacks. Okay, using EIGRP. Show IP, show interface brief. First check which are the loopbacks are available in R3. So loopbacks, we have 4 loopbacks with the 30, 40, 40, 40. Right? So enter into the global configuration mode. Router EIGRP 100. Okay. Network 172.30.1.0 and 40, right? Second one. 40.2.0 network. 40.3 and 4. Done. Show IP route EIGRP. So still is not forming yet. Okay, we'll check that one. Let me make it big. So from here, everything I'm going to access. I'm not going to frequently shifting to the routers, right? Okay. Exit. Then I will go to now this time R2 now. Okay. Cisco. Show IP interface brief. This 2020 we are running a network, right? So enter into the global configuration mode. Router EIGRP 100. Okay. Network 172.20.1.0. 2.0, 3.0 and 4.0. Today show IP route EIGRP. So now we can see these all routes, right? These all routes we can see. Understood, guys? Now check. Now I have in router 2, right? Now I want to shift to router 3 now. Exit. Then ping again, and this guy is, I think 10.1, I guess, right? I think 10.1. Router 1. Cisco. Yeah, I'm in router 1, right? Show IP interface brief. Check which are the interfaces. This is 10 series network. So let's configure this. Okay, router EIGRP 100. Okay, networks 172.10.1.0. 2.0 network, 3.0 network, and 4.0 network. Show IP route, EIGRP. You can see it lot of routes, right?
Yes.
Right. So from here, I can able to ping to all the loopbacks. So 172 dot, let's start from 20.1.1. Yes, I have the reachability. 2.1, 3.1, and 4.1. So now check for 30. 30.1.1. 2. I think 2 is not there. 30 dot. Is there? I think it start from 40 series. That router. Okay. So next you can see I think 40.2.1. So I can reach to these 3, 4, 5. So I can reach everywhere, right? So now ping to R3 computers, which is connected, right? Few computers are connected. So 192.168, I think 3.2, I guess. I think 2 are there. Yes, 2 is there. I think 3. Yes, you can reach. I think 4 also available. Right? Understood, guys?
Yes,
Yes,
Taj.
Taj.
Now, if you go to 3.100, okay, this is my R3. Okay, for better understanding, so better to give the name of the routers. Okay, so this I will give entity network security. Network security router. Okay, so I will exit. Then I'll jump to I think 2.100 R2. So this also will change with entity cyber security. Then I'll jump to R1. R1 is 10.1. This I will give entity cloud security. So if I ping to any one of these things, I think it will change. That's right. No need to jump here and there, right? This order, that order means to avoid the confusion. Okay, so once you configure this means, so you can able to configure all your routing protocols. Once the communication like exists, so we can able to use the telnet and we can configure. So most of the engineers guys, they will not access individually routers to configure. So for one individual PC, they'll access all the racks, okay, using smart console cables, okay, or we'll call it as this opta cable, which is connected for all the routers with a single access. The reason I have given this to understand you guys, because you'll be most probably you also working in big networks, because your people are network engineers now. So most probably I think you will be, this will very help you guys. Understood, guys? Any questions? Anjay?
Yes.
Understood.
Yeah, understood.
No more questions?
No question.
Okay, so can I give one small assignment using same topology, guys?
Yes, Taj, you can give. We'll do.
Okay, fine. So what I'm going to do, guys? Basic configuration required. So let me give one scenario. Okay. So this is my router. So use serial interface, guys. Okay. So use your serial interface. This is my R1, this is my R2, and this is your R3. Okay. And here, so I am going to use two switches. And this one also I'm going to use the two switches. Same thing this side. Okay. So here you connect end user devices. You also connect your laptop. And here also. Okay. So now what you people have to do here. So let me give some IP address range. Okay. So you select your own IP address. Okay. I don't want to give any IP address, guys. Okay. You select and make sure that what IP address I use, don't use that. Okay. Then you create four loopbacks. This is my loopback 1, loopback 2, loopback 3, and loopback 4. Okay, same thing from this side. Okay, so I'm not going to assign the IP address. Make sure that don't use the IP address which I have used it. Can you be able to do right now?
We'll try. We'll try touch.
Okay,
We'll try to do
so
it touch.
okay, so I think you'll be having use serial cable. I think you'll be having one more interface, and there you configure router on stick. I think which you have done on switching, right? So where we will be having two VLANs. Okay, this is VLAN 10, 20, and 30. Okay, so here we'll be running some PCs. Here also you connect some PCs. Here also you'll be having PCs. Okay, so but they should communicate with each other. And these guys should communicate with each other, vice versa. And this is optional. Once you complete that, you try this. Understood, guys? So can I take this screenshot? I'll send you right now.
Yeah, Taj.
Taj.
Okay, try guys, because you know this will help you guys. Okay, so let me take this screenshot. Okay. So I will save. So I will save in, yeah, so training will give EHRP. EHRP 7. So here I can see that. Yeah. So I'll share you in the group now. Okay, so topology has shared you guys. Okay, so try this lab from your side. All of you got it right? Topology?
Yes, Taj.
Yes, Taj, we got.
Yes, so try to do that lab. It's not a big one. I think you can able to do it, guys. Diksha, are you there?
Yes, Taj.
Okay. Can you able to do it right? The topology which I shared to you.
Yes, Taj, I'm trying.
Yeah. Guys, you're doing right? Anjay Ratnakar.
Yes,
Sharat.
yes, sir. Yes, Taj, we are doing.
Yes, Taj. Yes, Taj.
Yes. Try, guys. That is
Okay.
very good. That is the topology which I shared to you. Okay. So that is one of these thing production, guys.
Okay, we will try, Taj, definitely.
Yeah. So one of the customers, most of the customers, especially small customers, they use that topology.
I thought this is me, Anjay.
Yeah, Anjay.
I'm trying to connect this serial one, but unable to do that. I'm getting an error saying that the cable cannot be connected to that port.
So add serial module.
That I did, but still it's not working. You want me to
You
share
need
my
to
screen?
add. Yeah, share with the screen.
Give me a moment. Can you see my screen?
Yes.
This is what. It's no.
You're not. There's no serial interface in router 2. You need to add that one. Press escape key and add serial interface for the router 2.
Sorry, what did you say?
And for router 2, okay, add serial module. There's no serial module interface, right?
Yeah.
And check for R3 now.
What did it
Press
do?
escape.
That module when the power is. Sorry.
Just add one. Enough. Okay, I'll let it be. Go for router 3.
So cannot be connected to that.
There also you need to add serial module, right?
Here.
No, serial. There is a gigabytes ports. You need to add for router 3 also. Press escape key. Go to router 3. Add serial module here.
Cannot add
Power off.
module.
Power off.
One is fine, right?
Yeah, now you on it.
That I did, but still it's.
Now it will connect. Now you connect right from R1, R2, R3.
Yeah, now it is. Because earlier I did, I have added them, module as well, but that didn't. Okay, then thank you.
Okay, thank you. Okay. Guys, done?
Taj, we are doing Taj. Taj, have a doubt. We have taken 2 switches, right, for 1 router. So we have to make 2 DHCP. I think we have to configure 2 DHCP, right?
Yes.
They said we can configure after one configure after that we can configure one, right?
Yes. 2 DHCP for all 3 routers. 6 DHCP.
6 DHCP, yeah.
Such my query is like we are connecting two switches to one router, right? So default IP we're giving for one interface for one switch, and we cannot use the same default IP for the other interface for the other switch, right? So
Yes, we
how
can't.
this, yeah. So we need to create 2 separate gateways for 2 switches?
Yes, 2 separate gateway. That's the reasons like 2 connection have given, right?
Yeah. But
Right. That's the reasons I have given 2 interface. If we check my this thing, okay, we can see I have given 2 separate gateway for this. So example, this is 1.1. This guy might be 2.1. Okay, this is 3.1. This might be the 4.1. This might be the 5.1. This might be a 6.1. Like this we can give.
got it, Touch.
Got it, right? So try to do smart work, guys. How smart work? Okay, the previous file which how I copied, same thing you copy the same file, just add the switches, that's it. In this time, you would have completed the lab itself. I think you are doing right from scratch, right? Connecting devices, all and that, right?
Yeah, Taj, doing from scratch.
Do smart work, man. Smart work is very important. Amisha, are you there? Amisha,
Yes, Taj.
you're doing.
Yes.
Okay, same thing, copy the file, previous file, right? Let's just rename with the EHRP. That do the lab. That's it. Connect to 1 switches for the all those routers and configure DHCP. This one DHCP and then EHRP. Anybody has completed, guys? Because next topic I want to discuss MD5 authentication in EIGRP. Puneet, Sharath, you're doing?
Yes, Taj.
Okay.
For all three routers, DHCP completed. That's for my doing ERGP now.
Diksha, any challenges you are facing?
Taj, I am configuring DHCP for my second router. So far, it's going good. I'm doing.
Okay, good. Guys, you are taking long time, I think.
Sir, hi Taj, I'm doing last EIGRP configuration for last router.
Okay. What about others? Because you have only just 15 minutes left, man. I plan to take the MD5 authentication lab in EIGRP. Very simple lab, 2-3 lines command. Anjay, any challenges you are facing?
I'm configuring the DHCP.
Mhm.
Yo, ya कोई और बोल चल बे। Need to create out a law.
Hi, Taj.
Guys, done now? I'm a guest. We have 5 minutes left.
Hi, Taj. Hi, Taj.
Yes, yes. Srini.
Yeah, for first and second, I got EIGP, but for third, I am not getting. For first and second, I got.
Check the EHRP configurations in router 3, whether you configured 3 routes, right? You have to
Yeah.
configure, I think, 3 networks you have to advertise.
2 serial and 2 interface, right? 2 serials I have to configure.
1 serial and 2 switches in network, right? 3 total.
No, first for third to second one, 2 serial we have to configure, right? For third to second, we can
Yes, yes,
connect 2 serials and
Yeah.
2 interface, gigabit interface,
Yeah,
and 2
for the-
switches.
Yeah, for 2 switches. For the router 2, so 2 serial you have to configure.
Yeah, router 2 I configure 2 serials.
Then network might be your, I think, totally 4 network in router 2.
Okay.
Check whether you have configured it. Type show run. Check EHRP 4 network did you configure?
In a router 3 or router 2?
Router 2.
Show
Run.
Run. Okay. Okay. IP.
Press spacebar. Press spacebar. We can check EHRP. What are the network did you configure?
EIGP configured my network, which I gave IP addresses network, IP network.
Show me your screen. Share me your screen.
Is visible?
Yeah. Open your router 2 now. Okay, see, I could see your configure 30, 40, and 20. What about 10 network? One is missing.
No, serial to yes, CL 010/1/1 is there? No, 2 serials. 160.30 one interface and 160.40 another interface.
So 20 network is connected to R3, right? What about R1? R1? Type show IP route.
IP route.
Show IP interface brief. This is R2 or R1?
R1.
Okay, then go to R2. Give the router name, man. Otherwise, you'll get confused, right?
No, for first router I forgot. First, second, and third I gave. If I here also show IP into brief,
This is router 2 or router 1?
Router 2.
Yeah. Okay, here 40. There also we are given same 40 there in R1.
30-40. I took first two starting to same and last in the third I changed it for 10, 20, 30, 40, 50, 60. Yeah, third part.
I see. How can you give the 20 network here serial? Both network are same. First, this is R2, right?
Yeah.
Then how we can give 20 network for both the sides?
Yeah, I changed it last digit 231234. Like that I changed it.
It will not accept. That's it's showing down. Can you see?
Okay. Okay, I will change another. I will do another time. I will
Yeah,
remove this
same
IP
time.
address. Yeah, I will remove this one and I will do another.
Run. Show run. Press space bar. Again. Again. Yeah. See, you have configured 20, 40 this thing. So 20 network is connected to whom? R1 or R3?
R3, I think. R3, yeah.
Then what about R1? Which
No,
network you
no,
are running?
no. How I take IP address now? I will take same IP address for starting, but last I change it to 1234 last digit. I think that is the mistake happened. I have to change that one then.
Yeah. You should give the
Yeah.
network.
Yeah. Okay. Yeah, understand.
What about other guys? What about Kranti, Chandan, Diksha, Amisha, Anjay? Is it very complicated, guys? Guys, tomorrow is Saturday, Sunday, weekend, so please capitalize this advantage, guys. So again, next week, still a lot of things I'm going to discuss. Okay, so I think we'll stop the session, guys, here, and we will continue from tomorrow. Sorry, I think on Monday, right?
Touch.
Sure, touch.
Okay. Okay, so don't leave this lab. Okay, this lab is very helpful, guys. You can learn many things. Okay, then see you on Monday, guys.
Yeah, touch.
Sure, touch.
Okay,
Thank you.
guys. So take care.
Okay,
Happy
touch.
weekend, guys, and do
Yeah,
a lot of
happy.
labs, guys.
Yeah.
Okay.
Yeah, touch.
Okay, touch.
Thank you, Touch.
Okay,
Thank you,
guys.
touch.
Thank you,
Thank you,
Taj.
Touch.
Bye.
Okay, we'll see you
Touch.
Monday.
Thank you, Touch.
Thank you, touch.
Thank you, Sharat.